Iontra's technology overcomes lithium-ion battery failure modes so they can perform better. Batteries degrade with use. Innovations in the battery industry are mostly focused on developing new chemistries, materials, or construction to make improvements to battery performance. Lithium-ion batteries have an intercalation chemistry, where the anode acts as a receptacle for lithium ions. The key to charging effectively is to use as much of the anode surface as possible to get the ions in and out as easily as possible. Anodes have uneven, rough surfaces with high and low spots. Ions follow the path of least resistance and are more attracted to the high spots than the low spots. As charged ions, each gravitates toward the same high spots. This results in nucleation and hot spots on the anode surface that begin to build mossy, tree-like structures called dendrites. These dendrites amplify the problem by attracting more and more charged ions, and with more lithium atoms gathering in one location, they begin to plate across and cover the anode surface. As plating begins to form, it blocks the path for ions to intercalate into the anode, causing internal resistance, heat, and capacity loss. What's more, any lithium that plates on the surface, whether as a dendrite or as mossy lithium, reacts with the battery solvent and becomes unable to store energy when you need it, which starts the cycle of having less and less available battery capacity and use time from your device or vehicle. This plating and internal resistance also slow charging, as ions struggle to find openings to intercalate into the anode structure. Sometimes, the dendrites may grow enough to pierce the separator between the anode and cathode, and, in extreme cases, reach the cathode, causing a short and potentially leading to a runaway event. The non-uniform ionic activity of conventional charge leads to other failure modes, including uneven solid electrolyte interface growth, decomposition of the battery's electrolyte, cathode heating, and other issues. This degradation is accelerated with fast charging. New battery designs take billions of dollars and many years to commercialize. Application and product designers are working hard to overcome the limitations of today's batteries to meet the demands of their end customers. In many applications, battery performance remains a big challenge, as they take too long to charge, don't last the life of the products they power, cost too much, and use times are too short. Product engineers do everything from overbuilding their battery systems to slowing down charging to preserve life. For decades, the industry has been placing giant bets on next-generation battery chemistries in the hope of achieving better battery performance. Investors and corporations are putting billions of dollars into developing battery breakthroughs like lithium metal anodes, solid-state electrolytes, and various new chemistries. These efforts often take many years or decades to achieve practical performance, and even longer to reach the scale, quality, and cost to become viable commercial options for product OEMs. While several companies have been making progress in developing next-generation battery cells for the last 10 to 15 years, there have not been any new cells released with the volume, price, or performance to displace lithium-ion in a meaningful way. In short, designing and building new battery cell components and battery cell models is a slow, expensive, and arduous process. This is where Iontra comes in. Iontra. Energy Unleashed.